The topic which we'll be dealing in today's class of parallel programming is collective communication. Having seen process to process communication or point to point communication, now we'll move on to collective communication where a group of process will be involved in this communication, and they are being categorized into two types basically. One is your barrier communication, the other we call it as data movement. Coming to the first one, barrier or barrier. Now, when you go for barrier communication here, if you can see here, there are four processes that are being involved in the communication, and you want all these processes to stop at a particular point. So, to reach a particular point. So, here the process one has reached this point. Similarly, you want all the four processes to reach this particular point before they move on to the execution of the next one. So here after they have reached this point, they continue with their further execution. So this acts as a starting point for the next execution to be done, barrier. So you stop them all at a particular point and then continue their execution. So for this to be executed, we generally go for using a function MPI barrier, using which you can perform your functionality. Now coming to the next one, we go for data movement. When you go for data movement here, the first operation that would be done here is broadcast. As the name implies here, broadcast, out of the four process, collective means a group of process. So here I have four process. So one process will take the responsibility of sending the same message to remaining all other process. So this process 0 will send the information to process 2, same information to process 3, and same information to process 4. And if you want to perform this particular operation, it is compulsory that we go for including MPI.h, because these are all predefined functions. MPI underscore bcast, and this is a pointer to your data. So what is your data here? 10. Count how many values you are sending your data, only one. And what is the data type of this particular data? For this example, it is integer. And which process is broadcasting it? So here root is nothing but the ID of the process which is starting the broadcast. So here if I go for process 1, the rank of it would be 0. So I need to pass it, and this is the communication handle. By default, we go for using MPI underscore communicator. Now, we have already seen the basic message passing structure. So we need to start with MPI in it. We will be knowing the number of process involved in it by means of communication size, and the number of process would be stored in this particular pointer, yes, which contains the address of it. Now, here MPI communication rank will tell you the rank associated with each and every process. Now, if you want to execute this MPI broadcast, ampersand A is nothing but the data which you want to send, address of it. How many values? Only one values. The data type is integer. Who is taking the responsibility of broadcasting? It is process 0, and this is MPI communication world, which is a pointer for your communication to take place. And you have a printf before your broadcast, and you have a printf after your broadcast. And when you see this particular program, no way I'm using any for loops, right? But still, this particular statements, printf statements, will be printed s number of times. So what is s? S is nothing but the number of process which are involved in your communications, and this would be your finalize. So for all your data moments, these three lines as well as the last line would be same. Only thing is you will be having a change in the syntax of the function which you are using it. So if you are very much clear with one particular type of writing the program, remaining all other would be very easy for you. Now when I execute this, see here you got one printf before your broadcast and one printf after your broadcast. So try to understand the output here. Now, this particular code, whatever we have seen, you will be writing it in Visual Studio with C++, and you will be saving it this as .c. And you know how to build a program, so you have to just build it in VS Code. So after the building is done, building is done in your Visual Code, we'll be moving on to the command prompt. So at the command prompt, after you build the solution, you come back to your command prompt, and in the command prompt you see to that you are navigated till this particular folder. So whatever you have from your users tool till this debug folder, you navigate it, and MPI exec is the command what is required for executing your MPI program. These are your command line arguments. Hyphen n indicates the number of process. Here I am going for 4 process, and you have to pass the executable file of the program which you have already built using your visual code. So since we have seen before your broadcast 10, after the broadcast 10, because process 0 has the input, whereas process 1, process 2, process 3, initially they were all 0, and now they are being filled up with 10, 10, 10. And when you see the execution process, it is not that always you get 0, 1, 2, 3 in order. It will be executed by means of thread based parallelism, so you can get them in any order. And when you are executing the program for the second time, it is not required that you get the output in the same way. The next function which we have is MPI scatter. So scatter in the sense process 1 has multiple values, and this takes the responsibility of giving each and every value to different process. So since we have 4 process, so 11 will be given to some process, 12 will be given to other process. You are just scattering the values which are present with you. And for that MPI scatter, first of all, you need to have a pointer which actually contains the data. How many values you are sending it to each and every process? What is the data type of that particular data present in your send format? And you should even have a pointer to receive the data. How many values you are receiving it, and what is the data type of your received process? And here, which process is responsible for scattering the data? And this is your communication handle which is responsible for making the communication among multiple processes. Now, as I told you, these are your basic functionalities that are required. So initially r is equal to 0 means we are concentrating it on a root process or the starting process, we call it as, whose rank is 0. So I'm taking the initial value. So this particular process contains all 5 values. I'm storing them in a buffer. Now, when you go for using this scatter, similarly here I'm using before scatter what is the value, after scatter what is the value, and here you are just passing the rank of the process and what is the value that is present. So this is your sending buffer. How many values you are sending? One value. What is the data type of this particular thing? Integer. And where you want this data to be stored at the receiving end? This is the address of the receiving buffer. How many values it has to receive? One value, the data type of it. And who is scattering the value? Process 0. So the rank of it would be 0, and this is MPI communication valve. So since D is your receiving buffer, whatever value is there in D, that will be printed onto your monitor along with the rank. So when you execute this particular program, as I told you, the order is not important. So you get output of all the 5 process, but not specifically starting from 0 to 4. So initially all of them before scatter, they are stored with 0 value. And once you are scattering the value, each and every value, whatever was present in your buffer 1, 2, 3, 4, 5, 1 is given to process 0, 2, 3, 4, 5 are given to each individual process. Now, as reverse to your scatter, you have your gather operation. So what would you do in gather operation? Whatever you have here, 10, 11, 12, 13 individual values in the process, each of your process, you gather them and store it in a single process. So for that, we go for using MPI underscore gather, where you have a pointer to the data which you want to send, how many values you are sending, the data type of the sending data, receiver data pointer, count of number of receiving values, receiving data data type, and which process is to in which process you are gathering the data, and the communication world. So when you can just see here, D is just a value and you are just multiplying it with that particular whatever you have in this D, you are just going for multiplying it with 2, or you can directly take some random values here. So ampersand D indicates the data which you want to send, gather. How many? One at a time. The data type, and where you want to store them, all of them at the receiving side. It is the receiver buffer, receiver count, and this is the data type of it, and this is a process in which you will be gathering all the data. So when you see the execution part of it, if r is equal to 0 means this is a process where you want to receive it. So the data received by the process. So how many process you will be getting it by SB, right? So all the values you will be printing it onto the monitor. Now, when you go for the reverse case of your gather, this is MPI all gather. So in MPI all gather, you take the values from each of the process and store it. All the four values will be present among all the process. Whereas when you go for your gather operation, only one process was having all the values and the remaining were not having any values. Whereas here, all the process will have all the values which are being gathered. So here it is all gather. Same, the data pointer to the sender data, number of values, the data type, the receiver data, the count of your receiver data, and what is the data type of your receiver data. So if you can just see here, ampersand S will tell you the number of process, R will give you the ID. So MPI all gather. So what is your sending buffer where it is present ampersand D? And this is the data types one at a time you want to send. This is integer and this is the receiving buffer at the other end. Since you want to gather all the values, I'm just going for using a buffer here. So this is an array. So because all the values from all the process will be stored in this array. How many values? One value at a time, and this is your data type and communication world. So the data received by each process. So first time the rank would be 0 and it prints all the 5 values. Next time, so here you are only writing a for loop for printing the 5 values. But how many process? 5 process. So I am not using any loop to print the data for 5 process. For each process to print 5 values, you are using a for loop. So when you actually execute this program, if you could just see data received by process 2 initially. So this is the value. So starting value is 0. Next time it would be 2, 4, 6, 8 because you are multiplying the value into 2. 0 into 2, 2 into 2, 4 into 2, 6 into 2. Sorry, you are just adding up the values. Instead of the multiplication operator there, you can just go for plus. 0 plus 2, 2 plus 2 again 4, 4 plus 2 6, 6 plus 2 8. So in the code you just replace your star operator with d is equal to 0 plus the rank value, or this is rank value plus 0. Rank value plus 0, and these are all the values. So all the values are gathered up in each and every process. Now, when you go for MPI reduce, so when you see this MPI reduce, whatever values you have in your individual process, here I'm just summing them up. 1 plus 2 plus 3 plus 4. I'm performing a summation operation and storing it in a single process. You are reducing it. For that, you require a pointer to your sender data. You even have a pointer to your receiving data. What is the count? What is the data type you are using? And here we have an operation. As I told in previous case, I am performing summation. You can even perform average of the values which are present. You can even perform multiplication. You can go for performing subtraction. You can find out a maximum value out of all the things or a minimum value. So I have to be very much clear with the operation that I want to do on all the values and reduce it to a single value. And which process will take the responsibility of reducing it? This is your root value. So ultimately the reduced value will be stored in your root value. Now, as I told you, this is MPI max, minimum, sum, product, logical, or, and, or operation. So you can use any of these operators. So when you just concentrate on, so here initially in each of the process you have a value 10. So 10 plus first process will contain a value 10. Second process will contain a value 10 plus 1 is equal to 11 because it is the rank value. 11 plus 1 is equal to 12. 12 plus 1 is equal to 13. Depending upon the number of process, that many local values you will be getting it here. And this is your sender data. This is your receive data. After you sum up all the things, it will be present in your global sum. And here what I am performing, it is MPI sum. Finally, that particular reduced value will be present in your first process. This is rank 0. So when you could see this, and similarly, where you have all that is related to reduce, where the result would be stored in only one process. But if you want the same result to be stored in all the process, so what is the other operation we have here? All reduce. So if you can just see till now, we have completed barrier operation at the starting. Data movement is nothing but your broadcast. Next, we have seen gather operation. In gather, you have all gather operation, and similarly, you have your scatter operation. You have your reduce operation which will be performing your reduce function, and you even have your all reduce where it performs summation or average values. So same received data and the operation. Coming to this, after you execute this all reduce operation, the result of your all reduce will be stored in individual process. So if I have the process P0, P1, P2 and P3, each of them will be having the result. So initially if I take the values as 1 2 3 4 5, and if I perform the summation, the summed up value will be present in each one of this. So you'll call it as all reduce. So these are some collective operation which we will be using.